Now we will give an example of a degraded broadcast channel. We consider the following stochastical degraded binary symmetric broadcast channel. In this channel, x is equal y1 equal y2 0 equal 0, the set of 0, 1. So we have only binary alphabets. And y1 is equal x plus z1, where plus is the plus modular 2. And y2 is equal x plus z2, where plus is also here taken modular 2. And further we said the probability of z1 of 1 is equal 1 minus pz1 of 0, that we call p1, small p1, and pz2 of 1 is equal 1 minus pz2 of 0, this we call p2. So x, z1 and z2 are statistical independent. And we suppose that p1 is smaller equal p2 is smaller equal 1 over 2. Now, how we can see that this channel is stochastically degraded? So we can form it to a physical degraded channel by writing it in this form. Epsilon1 is still x plus z1, and epsilon2 we can write as x plus z1 plus z2 prime. If you think about this, here we have plus z2, and this we can find a z2 such this is equal z1 plus z2. And then you see obviously that this is now a physically degraded channel, where this is a stochastically degraded channel. Now, if you want to calculate the probability of z2 prime, then we get that p of z2 prime of 1 is 1 minus p of z2 prime of minus 0. And this we can write, we can just use these formulas here and show how it's calculated as p2 minus p1 over 1 minus 2 times p1. And z2 prime is independent of x and z1. This follows by solving this equation here. The bounds on the cardinality auxiliary random variable u is binary. And by symmetry, the distribution of u that maximize the rate is uniform, a uniform distribution on 0, 1. So therefore, we can choose pu of 0 and p of u of 1 equal 1 over 2. And we said that the probability of x not equal u is equal to q. Now we can evaluate our formula for the binary degraded broadcast channel, what we have before. And then again with p star q equal p times 1 minus q plus 1 minus t times q, we have that R1 is lesser equal than H2 of P Q star P1 minus H2 of P1, and R0 plus R2 is lesser equal 1 minus H2, so this is a binary entropy H2 of Q star P2. And this really defines the capacity region of this channel, because it's known that this is also best possible. I think this is a nice thing what you can do in details for yourself, because it's just applying our theorem and putting in the formulas. It's also a nice way to see what is the difference between stochastical degraded and physical degraded. Stochastical degraded just means that there is a physical degraded channel with the same marginals. And this is obviously here the case.